even if it is not included in the exam, you may have to teach some certain points like that. And also, we have very few days, but there is a whatever is really very important, which you should not miss out, that you should identify so that the children can do better in the 12th also. Then study material, support material. Last year, the first material was all full of MCQs. Now again, assessment patterns have changed. So I'm sure you'll do enough. You just have to do a bit of work there to find out what all portions have been deleted, what has been added, and then make the prepare the questions as per the new assessment pattern. So all these you all are aware of. I just want to know what time try and finish off the support material by end of August or 12th. And 11th also you all have prepared. And I must congratulate all of you for the books support material, because there were a lot of people, parents also have informed that the study material was of very good use. Maybe that is why our children have done reasonably well. Anyone got 100 on 100 in physics? Any teacher where a student has scored 100 on 100? Because I think we didn't see, we were just discussing, so I thought all of you are there. Is there anyone with 100 on 100? Because I think chemistry is full of hundreds. I mean, a lot of children, but yes, probably I don't know. What is the reason behind that? Was the paper very tough?
Term one was tough, madam. We have 99 KV rubber board.
Okay, KV rubber board is having 99. 99, I think maybe there may be others also. So I think we missed 100 in that. And yes, you can just reflect on your result also. And the teachers are trying. 99 is as good as 100 in physics. Physics is not a very easy subject for children, especially where suppose they don't have math, then it gets to be even more difficult. So you will have to plan out now itself for the next year's coming year's result. COVID or no COVID, now you have the children who have completed 11, and just you don't have to wait for any tests to find out who are weak. You can straight away identify those children and start working with them. And also in your study material, please see that if some portions can be really marked where things at minimum, that learning material is there, where the children who are not so very good in physics, what should they concentrate on to at least get that 33%. No child should, I think a teacher can help any child get at least 33. That is not a big issue. From the beginning, if you take care, there are examples where the teachers have really worked with the children. Very weak students also who never had any idea of physics also have managed to pass with that minimum. So these are the things that you have to discuss, and then reduce syllabus is for more time for experiential learning. What are the practicals? What are the activities to be given? Where should children learn on their own? Or how much of involvement of the child should be there in every topic? What are the pedagogy to be adopted for each topic? So these are some of the things that you can discuss and share with each other, which you find is very successful in each particular topic. I'm sure with all your experience, you have a lot of experience, many of you many years behind you are doing really well. We don't have to tell you about all this, but just one reminder. Sometimes we ourselves get bored over a number of years, sometimes we might get bored. So it's just a reminder to all the teachers, yes, we have the potential to do even better, and KV and Nagin has done very well because everyone has worked as a team. So we hope that results continue to go well, and this year definitely we are going to get a children. Hopefully, we keep our fingers crossed that children come to us for right throughout the year. Unlike last year, where yes, we got our children only for very few days. So that problem was also there, and especially where a lot of guidance is required, like in maths and physics. That those few days we have lost out. But in spite of all that, I think our teachers have done wonderful. So congratulations to all of you, and I'm sure this year we will start from the very beginning. We've had now this workshop which was conducted quite late last year, just before term one. But this year we have started, I think very much well in time. I hope all of you bring out wonderful support material once again for both the classes, and all the best to all of you. Thank you, Hema Madam. Yeah, thanks a lot. No? I shall disconnect now, and thank you for a very patient listening. I don't want to take up too much of time because I think we have another meeting in the afternoon, and I don't want to eat into too much of your time because your meeting is also will be after 3 o'clock. Thanks a lot.
Thank you, madam. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Yeah, ma'am.
Thank you.
Yes, Ramachandran sir, as madam told, we have a meeting at 3 o'clock also. So I think we can hurry up, start fast.
Thank you, madam. Good afternoon, friends. So after a very serious discussion in the morning session regarding the planning, syllabus and all those things, we are planning to have some a few activities. Competencies, of course, I believe any competency can be built only on conceptual understanding. So the most important part of this entire uh, program is how to make the children understand the concept. So here we have planned a few activities which can be used for that. The past 2 years we have been using the online platform. There are plenty of built-in videos, activities available, and it was very easy to use it in the platform. But as far as the effectiveness is concerned, we believe that it is always better if they can directly see it. So we have used some of the items available in the lab, plus one or two equipments from those which we have received under the scheme of modernization of lab. As you can see behind me, this shelf contains all the equipment we have received there. So some of them. And let me first start. Before that, I thank two of my colleagues and friends, Jyoti Madam and Jayalasan sir, who are behind this. You will only hear my voice, and my contribution is only my voice. It is all because of my friends. So let us begin. So first, we are going to show a simple activity of mutual inductance and mutual induction. So we have used a step-down transformer, which we are using for AC transformer experiment, and these coils we have wound, and there is a core material used there, and the secondary coil is connected with the bulb. So we will see once the input is given, output is produced, and the bulb glows. And we can also see that when the coils are moved away, the coupling decreases, and the induced EMF decreases, and the glow gradually decreases. So this simple activity, the children can see if they want, they can perform also. So let us see how it starts. Bulb is not visible. Now see, as the distance is increased, the intensity is decreasing. When it is closer, it goes like that. Okay, this is the first activity. We need a AC step-down transformer and it will be a copper wire and a form material. Now next we pass on to an activity that shows the behavior of a current carrying coil in a magnetic field. Once again, this is simple improvised coil, and we have used a powerful magnet below that, and you can see the source in the background. And now once the current is allowed to pass through, the coil shows the response. Magnet can be seen below. So very smoothly the coil rotates, and children can see that. So very less effort is needed, but I feel students get a better perception about what is happening here. We can change the direction of current and see that the coil rotates in the reverse direction. So next we have, this is a ready-made equipment. Faraday's coil magnet experiment can be beautifully demonstrated using this. As you can see, there are three coils with 2500 turns, 5000 turns and 7500 turns. And terminals are given there, and an LED is provided there. You can show that LED glows due to mutual induction, but I prefer to use a galvanometer so that the reversal of current can also be seen clearly. Otherwise, the LED glows both ways. They won't get an idea that when magnet is introduced, the current is in one direction, and when it is taken out, it is in the opposite direction. So very compact equipment, but I hope children enjoy this. Okay, madam. And needle is to focus. Ah, yes, yes. Now the needle can be seen from the focus. Yes, and coil is introduced, it deflects in one direction. When it is taken off, direction of deflection changes. And both can be seen together. Meter and coil. Little back. Ah, yes, yes. From that distance. We are using a mobile webcam. Focusing. Yes, I think the question can be seen, I hope. So if the glare is there, if you switch off the light, the lab is looking dark. Okay, so yes. Now it is, yes. So this is the third activity, and just one more. And this is the behavior of a current carrying conductor in a magnetic field. Once again, I will improvise the mechanism. And you can see this is a conductor which can move. Conductor is an isolated conductor is used and we make a temporary connection. Just like we are making a brush mechanism there. A stack of powerful magnets kept, and above also there is a magnet, and now yes. Because the magnet is very powerful unless we hold it. So what is in your hand? That's better. Don't use this thing. Yes, with one magnet also it works. Current direction can be changed, and you can see the difference in the response. Yes. So these are the four activities. We have actually shown this in the class, and this what we believe, because my friends actually I am greatly indebted to, as I told earlier, both of my friends who are very much active in this area. They find ways and means to make things and solve in the class. So thank you one and all. Over to who is the next? So who is showing the next one? I just hand over the.
Suresh sir.
Okay, thank you, Ramendra sir. I will take only 5 minutes, madam, because some of the things which I want to tell I told in the morning, and I will be adding upon on that, and along with whatever Ramendra sir has told, the importance of doing practicals and learning. Because by learning by doing is always good in physics. So I will just share one video, one screen. I think you can see my screen now.
Yes, sir.
Yes. So one video is that video is little long, so that I will not show now. So as I was telling in the morning, NCERT syllabus or CBSE syllabus has 30% weightage on practicals, and these practicals are very, very important because it clarifies the concepts for every student. If they do it sincerely, it clarifies the concepts behind that. So through practicals, a science student is supposed to get some skills or competencies. As madam was telling in the morning, skill and competencies are both the sides of the same coin. So this is what I wanted to tell you in little more in detail. These are the 10 competencies NCERT has enlisted, which they can acquire by doing practical sincerely. First one is comprehend. They want to comprehend the theory and objectives, so the capacity of comprehension will definitely improve if they do the practicals and write them properly. And if they want to get the answer correctly, they have to do the experiment systematically. So the second competency is how to get the things in a systematic manner. And they have to go for precise observations. They need to substitute, calculate, interpret all these letters, words which are given in letters are, red letters are the competencies which they are acquiring through practicals. Drawing skills, because definitely when they are doing practicals, they have to draw prayer diagrams, circuit diagrams, and they have to label them, and they have to give directions for them, and they have to plot graphs, and finally they have to report to us, because reporting is a very good skill. They have to report, this is what happened, whether it is right or wrong, and finally they have to summarize it. And definitely if the practicals are done properly, they will have definitely a vigor for doing the investigative project. So the exploration skill also will be developed through practicals. So these 10 skills, actually this is not 10 skills, more than that. This is given by NCERT, not by me. It is given in the NCERT curriculum, which they can acquire by doing practicals. So my question is, these skills or the competencies what they have developed through practicals, are they helping only in practicals? What is your opinion? Are they helping them in theory? My answer is definitely yes. Definitely yes. So let us try one small numerical question from fluid dynamics. Just one small question. What is traveling from an overhead tank to somebody's house? You can see that the water, when the water travels, it is traveling through pipes of different size. What can be the reason? The second part is a numerical part, and the third part you can see why domestic connections are done with the much smaller pipes. So I'm 100% sure that the second part anybody can do, even any child will do, because it is a question of continuity. And if a question of continuity is there, definitely there is a proportion, and you can write that A1 B1 is equal to A2 B2, and you plug in the values, put the values there, and you can get the answer. And the answer is 1.25, something like that. So that part there is no issue. But if you want to answer the first part and the last part, you need to use some of the competencies what you have developed there. So can you remember, or can you enlist some of the competencies which they have already developed in the through practicals they use here, knowingly or unknowingly? Any competency how they are done, how they use when they are doing a numerical, a simple numerical like this?
Applies, sir. Applies the knowledge.
Applies the knowledge. Then it cannot be one. It can be a combination of many. So since the time is short, I am not waiting for getting the answers from you. You can see observation was there, analysis of data was there, computation was there, drawing was there, problem solving was there, interpretation was there, exploration, much more ability they have to acquire for solving such questions. So if a small question like this is making use of competencies like this, then bigger questions definitely have to make use of more number of competencies. So competencies which they develop through practicals has to be continued, and it will definitely help them in theory also. So my sincere request to you is let everyone do the practicals sincere. Okay. Okay. Then one as a tail piece, I will just add one question connected to this particular question. Plumbers, now when they do plumbing line in high-rise buildings, they will use a technique called reduction. Reduction doesn't mean reduction zero or something like that. What they will do is they will give connections to the ground floor or the first floor with a 1-inch pipe. When they go to the third or fourth floor with a half-inch pipe. When they are going still higher, a 1/4-inch pipe like that. What is the physics behind? Any physics is there? You can pick up one. Tell me later, no problem. Anybody, any physics which the plumber is using in the in this reduction? No problem. So you can think about that. So competencies are not only developed through theory, it has to be developed through practicals, because learning by doing is much easier and better than learning by reading. If you read, you will understand, but if you do, you will never forget. Thank you, madam.
Thank you, sir. Next is Vilesh, sir.
Thank you, sir.
Good afternoon all. Mr. Hemamara, Principal in the PC Triangulum, and my dear teachers. So myself Vilesh, I'd like to present something related to competency based learning or education. Actually, after NEP, we have given more importance to this competency based learning. I hope you can see my screen. So some communication issue. I was also taking the same topic as Ramazan sir done. So I still remember in my childhood, teachers are coming to class and they are saying the definitions, for example, electromagnetic induction for a couple of times, and we are just learning it and writing in the paper, and we were getting marks. After the field got changed, the experiential learning as well as competency-based education, that is the development of skills, have more important than the questions coming for exam. They are based on these kind of competencies. Students should learn from their experience, not from our olden days teachers and their learning. And we can introduce this topic to children by electromagnetic induction, by experiment as sir has shown. And nowadays simulations also available, which is also we can use for teaching. One of experimental learning means we can include the participation of students, and they will get more experience and they will learn from that. And simulation, some advantages are there for simulation also, because there will not be any error, because it is a program, pre-planned program, so we can do without any error. By doing experiments, there may be some problems. Sometimes we will not get the exact result what we expect, and students may answer what's the problem. Then it's also a type of learning, obviously, but still we can use both these techniques. And lastly, I covered them this chapter, electromagnetic induction and Lenz law, obviously. And I have given this question, current passing through a wire AB is increasing, in which direction does the induced current flow in the loop? Even though they know, if I am asking them what is Lenz's law, they are giving the answer, but they could not answer to this question, some of them. So I took them to the lab and introduced one of the items we got to modernization of lab, which is the ring launcher, which working based on the electromagnetic induction as well as Lenz's law. So let me present the video. This is our ring launcher, and we have a soft iron core with it, and we are inserting this soft iron core inside this. This is a magnet. This is a coil. When we are applying the electricity, it becomes a magnet, and by using this soft iron core, we are enhancing the magnetic field in that region, and in this region, and also this iron core, that is a ferromagnetic material, and we can recall the things we already covered them in the previous chapter. And the other parts of this device are aluminum ring, aluminum complete ring is there, and then we have again an aluminum ring, but it has a small split, it is not closed, and yet another ring made up of plastic, and coil having a couple of woundings, and bulb is attached to one end. So last day I made the students to execute this experiment, or to operate this device, and they have done it, and this is a plastic collar so that we can adjust the height, and once we insert the ring in this place, actually this ring is a complete ring, as I said, and here we are having a AC supply. We are applying an AC supply to this coil. You can see the coil copper wire is wounded, and AC supply is coming. So it creates a varying magnetic field, and as we know, we are all familiar with this kind of a device. Once we are apply the trigger, we can see the ring which is moving up. And again I'm repeating the experiment, and last day students have done this, and they have found the reason for the same, and we can do the same experiment for the ejection of or launching of the ring by dipping it in liquid nitrogen, but it's not possible. If you are dipping in liquid nitrogen, we can launch to a more height, and again we can recall the idea which we taught them during the third chapter, that is negative temperature, positive temperature coefficient of conductors. As the temperature decreases, resistance also decreases. As a result, there's an increase in current, and here the launching height, that is also moved. So we can connect these things with the previous knowledge, and then we are repeating the experiment with the split. The splittering also we can use. I'm just skipping the video. So this is splittering. We can repeat the experiment, but as we expected, we do not see any launching because the circuit is not complete. It is not closed, so that there is no induced EMF, and plastic again, and it also does not show any launching or a. And next is a wire. Here we could see the bulb is glowing, and it is because of mutual induction. We can teach on another topics, the working principles of transformer, which is here. It's also we can this idea also we can give to our students. And after showing this video, that is the induced EMF always opposes the cause. Then again I ask them to solve the problem. Most of them they are able to find the answer that the current induced in the loop, which is trying to oppose the cause, that is the change in magnetic flux. And this is the same kind of problem. Here also students were able to answer, and they found the direction of current generally induced in this both the coils, both the rings. And it's another question. Just discussing a few questions. I know we are all familiar with this kind of questions, and we can implement the part of practical or experiential learning so that the student will be able to do this kind of problems by their own. Otherwise, we have to give practice in each and every question. So choose spherical balls on metal and other one is glass. We are dropping from the same height. Then which one will reach the earth or ground first? In class 11, we are seeing the acceleration due to gravity is independent of its mass. So both of them come to earth at the same time. But here, one is an insulator and the other one is a metal. So insulator has no induced current and there is no restriction, so it will reach earth first. So this is what I'd like to share, and would like to convey my gratitude to the organizers for this opportunity. Thank you all.
Thank you, sir. Prashant, sir.
Yes, ma'am. Am I audible now?
Yes, sir.
Good afternoon to all of you. First of all, I would like to thank Amma ma'am and DC for giving me an opportunity to express my views in this platform. As I feel this session is not for covering all those activities for explaining the various competency, how to deal it. It's just like a sample how we should adopt in the class. That's what I felt. So I'm not here with any experiment or something. I felt one of the concepts in class 11, which is connected to class 12, and which most of the students find difficult to apply, where even the brighter students. So some questions I can show you that the previous year board questions. This type of questions where the charged particle, whether it is electron or proton or any other, will be moving in one direction, and the magnetic field will be acting in the other direction. Then finding out the force. That is using the Fleming's left-hand rule, or using the Lorentz magnetic force, or it comes to Weierstrass law, where it is real cross R. In all these areas, you know, the knowledge of finding the direction of cross product is very crucial. And most of the time, children get confused when it comes to minus x-axis, minus y-axis, etc. So if you adopt a particular approach so that every children can answer, I think the aim of competency-based learning will be executed properly. So I used to adopt this technique in the class, and even the lowest achiever used to come up with the correct answer. So I thought of sharing that method. Two ways I used to adopt in the class. One is using the right hand palm that all of you may be using, but how I used to insert the point properly. That is, suppose you have normally the two vectors, one vector here, the other vector here. This is the simplest case of it, where everybody will be telling the answer. So whenever to find out the cross product or the direction of this cross product P vector, I insist the first vector should be your B finger, and you have to keep those fingers in that direction of first vector, and you have to rotate this palm towards the second vector, that is the right hand grip tool, and then the thumb will be showing the direction of the cross product. So you can see here, if you point out your palm here to this A vector and rotate it towards the B, the right hand thumb is into the plane of the paper. This is simplest case. But when it comes to other orientation, also this way of application. For example, suppose you have a vector which is like this, that is this representation is coming out from the plane, that is suppose the V vector, and the next magnetic field vector is in this direction. Maybe in the question it is mentioned like the magnetic field is along east and the particle is moving into or downward, then what will be the direction of force? So in this case, we have to keep our straight finger, that is the first vector, because the force equation all of you maybe or the children may be knowing, it is Q into V cross B. So to find out the direction without any confusion, keep the straight four fingers downward. Here it is coming upward, so it will be out of the plane. Now we have to rotate this palm towards the second vector. If you rotate it this way, it will be towards the left, and that is not the direction of the second vector. So naturally we have to keep it in this way and rotate towards the right side. So ask the child to rotate from the first vector towards the second vector, and then what should come? He will definitely say it is upward in this direction, and that is clearly seen that it is towards north direction. So without much complication, the child can reach to the answer. This we can apply in various situations like in this way, and cross, suppose if this is one vector, maybe the velocity vector is downward or downward, otherwise you can say it is acting towards south direction, so that other directions are like this. Then the velocity vector is towards south direction, so we will be keeping our straight finger towards south direction, and the other vector, that is the magnetic field vector, that is into the plane. So from south into the plane means we will rotate it downward, so that his thumb will be showing towards the east direction, so that he will write the answer towards east. But this approach, again, there will be a few fraction of the students who will always find it difficult again to find out this north, south, east, west direction properly. So for them, an alternate option, as we used to do mathematical, write I, J, K in clockwise, and using this arrow, if it is I to J, J to K, and K to I. I think all of you may be using this way of writing, so that I cross J we will say K. But the problem comes when it asks minus I cross J equal to what? So in that case, just inform them, you find out what is I cross J, and if one minus is coming, put a minus on the other side also. That is, K is already there, that they know from this particular method, I cross J is K. If one minus is there, right side also one minus. Now, if there is two minus, like minus I cross minus J, then two minus on the right side also you have to put, that will automatically become plus. So that minus I cross minus J is plus K. So if a question comes like a proton is moving along minus x-axis, that is, it is minus I cross, and a magnetic field is acting along minus z-axis, that is, it is minus k cross. So he has to find out what is minus I cross minus k. From this, already we know I cross k, it is, since it is in the opposite direction, I cross k means it is minus j. that we used to teach them. If it is in the anti-clockwise, it is negative. So I cross j, already we know it is minus j, and we put two more minus there. Because of minus I cross minus k, so two more minus means total three minus. That will be again remaining one minus, and minus j will be the answer. So without getting into the confusion of these palm rule and rotation everything, they can easily say the force will be acting along minus y axis. So if both of these methods together, if we explain to them that finding the direction of cross product confusion can be avoided both from the bright students as well as I think the low achievers also. Because low achievers may go with the second option and the others can deal with the first method. That will cover all the 6 directions including upward and downward as well as north, east, west and south direction. This is one of the small points which I wanted to discuss. Not much big idea, I know. You may be having more better ideas than this. Anyhow, thank you for listening to me patiently. Yeah.
Thank you, sir. Srikanth, sir.
Good evening, respected principal, that is course director Hema madam, and good evening all my friends. Actually, I made some PowerPoint presentation, it is not getting on. So I thought competency it came down. What to take in front of you. Okay, no problem anyhow. Now, what Prashant sir told, from there I am starting. Actually, cross product. Usually, when I go to the class, direction of cross product, how I introduce is just to look at the leaf of the fan. 2 leaves are there for a ceiling fan. Then the axis shows the direction of the cross product. That is both perpendicular. How it will be both perpendicular? That is the usual way. Then another question it came to the student is, sir, area is a scalar quantity and how it will become a vector? Actually, I prepared for flux. So usually we are taking area as a scalar quantity, and here we are taking it as a vector quantity. When we are teaching flux, because we are introducing another one more concept of normal impact. So I just that is take how it is considered to be a vector quantity. Please excuse me. Actually, for me. Presenting my screen. Consider we are having x-axis and y-axis, we are keeping this, consider a small area here. That is, I am keeping a rectangle or square area. So O is the origin, A. See, AB is the length and BC is the breadth and height. So instead of simply multiplying, we are taking L cross B or B cross A. So either we can consider L cross B or we can consider B cross L. So when we are considering L cross B, sir already told it will be both perpendicular to L and B. So it is both perpendicular to L and B means it will be perpendicular to, that is x-axis and y-axis, that is Z, or it can be along minus z-axis. So it will be along Z means this will be along minus z-axis, because as sir told, it is I and J. If you are considering I cross J, it will be K, and J cross I, it will be minus K. Usually, some students will ask the question in the class how the area is considered to be vector quantity. So we are just, I am introducing this like this. If anything is wrong, just correct it now. So this is a concept of area vector usually. Then about flux, usually we say flux means the electric lines, magnetic or electric, the lines of force crossing perpendicular to a area. So if you are asking the question to the student, see, if I am keeping a uniform electric field, I am keeping a disk of area that is disk of radius r, what will be the flux? They will tell phi is equal to E dot ds. So E dot ds means E is the uniform electric field and ds is the area. Area of the disk is pi r square. So E into pi r square. This will be the flux. The same electric field, if you are keeping a sphere of radius r, I am keeping a sphere of radius r, what will be the flux associated with this one? So if you are keeping a sphere of radius r, what will be the flux associated with one? So no need to ask, everybody know. So the flux associated with the sphere is, usually students will tell, sir, it is E into area of the sphere. Actually, we will not consider the area of the sphere, where we have to consider the total circular projected area. Because sphere, when we are considering the thought, the electric lines are going to inside, but we have no need to consider the area of the sphere. Instead of that, we have to consider a circular, because this is up to this much only flux is going. Here one circular area, the same radius r. So here also flux will be E into E dot ds, that is if you are considering this normal, then E into pi r square. This usually students will make. Every time students are making the mistake in this question. If I am keeping a sphere of radius r, what will be the flux associated with that sphere? So actually, instead of considering the area of the sphere, we have to consider the total projected area of the sphere. Then another question usually I ask in the class. Usually we teach the students, if we are keeping a charge particle, or charge particle is moving perpendicular to a magnetic field, it will constitute a circular path. So that we are teaching in electric, that is magnetic effects of electrical. If we are keeping a charge, it will experience a force, that is F is equal to, if it is in a combined electric and magnetic field, we know it will experience a force, F is equal to QE plus Q into V cross B. Now this is in an electric and magnetic field. If the charge particle is allowed to enter in an electric and magnetic field where the magnetic field and electric field are parallel to each other. See, I am keeping axis, x, y, z axis. If these fields are parallel, this is the electric field and this is the magnetic field and this is the motion of the particle. Then what will be the trajectory of this? Because after teaching this, just I put a question, how many of them clearly understood the concept behind it? So what will be the trajectory and what will be the distance covered by the charge particle after any time t? So we can very easily calculate it. Because electric and magnetic field both are parallel to each other. So here usually electric field L, right, E is equal to E I cap, then B into I cap, then velocity vector V is equal to initial velocity V0 and I cap. All are in the same direction. So total force we can consider F, that is electric field, plus F magnetic field. So it is equal to QE plus this is velocity and magnetic field are in the same direction, this 0. So total according to second law, F is equal to ma, it is equal to QE. So A, again we know that A is acceleration, so A will be resolved into 3 components, AXI plus AYJ plus AZK, and is equal to Q into EXI, and both J and K components are 0. So here there will be no acceleration in the y direction, so and z direction it will be 0. So m into AX is equal to Q into EX. because E and EX are in the same direction, so only so acceleration along the x direction is QE by M, and the equation of motion, that is displacement along x direction, x is equal to, that is s is equal to ut plus half a t square, s is equal to ut plus half a is QE by M, M into t square, and only few students will solve this one. Majority will not solve. If the students who are solving, another question we can give in the same way. If the charge particle is entering perpendicular to both electric and magnetic field, we know it will constitute a circular path. What will be the displacement? So anyhow they will have to solve much on that. So what will be the displacement of the particle? That will be displacement won't be in one direction because it will constitute a circular path. Imagine, that is I will not explain it. We can solve it. You know, everybody can solve it. So this is a y direction. Y, x and z. If I am considering that is magnetic field is on along y direction, and see charge particle is entering in this one like this, x direction, initial velocity. So if the charge particle is entering perpendicular to a magnetic field, it will constitute a circular path. Here according to Fleming's rule, so it will constitute a circular path in this, that is xz plane. Once it is considering in an xz plane, so simply this x, it is z plane. So it will constitute an xz plane. Then the velocity will be changing, because every point the direction of velocity, see, magnitude of velocity may be a constant, but direction of velocity will change. Here this is the direction of velocity, here it's the direction of velocity. The velocity what it make with x, that is x axis. See here I am taking an angle phi 1, this is a velocity v1 I am taking. Here the velocity, the angle is phi 2. When it is coming here, this is the x direction and this is the angle, then phi 3. When it is coming to this point, it will be again 2 pi radian, that is the angle will change from 0 to 2 pi. So we have to consider that also, it will become much complex. So we can solve the question very easily by that is considering x and that is that component of velocity as well as position. So these are the questions usually I'll give some students. You know, majority it is not, that is for slow learners. It is for somewhat in our class higher achievers are there always. So these questions are really helpful to them. Lot of orientation we can give. What will be the orientation? No need perpendicular. Here I consider only magnetic field. Next one we can change the question. Electric and magnetic field can be given. Electric and magnetic field are in, that is same direction, and particle is entering perpendicular. Then what will be the path? Then the beauty of the question came, because it will not be in a spherical path. It will be in a elliptical path of increasing the pitch, because if you are considering this direction, both magnetic field and electric field are there, and charge particle is entering, it will constitute a elliptical path of increasing radius. So we can tell them to find the pitch. See, if we are taking this P1, P2 like that, so always P2 will be greater than P1. So like that questions we can give for the students, those who are able to, or somewhat higher achievers of the class. So it will be more interesting for them to solve the questions. Once they are getting the question, they will be much attracted towards the future or towards the subject. They will be much. So this is my experience. Actually, I made the PowerPoint and all the stimulations with Flex. So in any other occasion, I will be using, or otherwise I will post it in the Google Classroom and I am getting the chance. So thank you. Thank you.
Thank you, sir. Sachu madam.
Yeah. Good afternoon, Hema madam and all others. Myself Sachu from KVA Satna. I'm so happy to be a part of competency-based education activities so that we get our classroom transactions better. So as we all know, this competency we think that's being reached to children only when they start doing or when they start applying the concepts what they already know. So for that aspect, it's very important to give them a variety of learning formats. So for which we as teachers use to try different methodologies. So methodology that selection is very important so that getting children with whatever competencies what they require for that can be done. So here I would suggest choosing simulation as one of methodologies because every activity in real life we can't show them. So we can go for some of online platforms. I hope you can see my presentation. You do, right? Do you see my presentation on please?
Yes, ma'am.
This is that one of methodologies I would like to suggest. Say I was say one of online platforms. They through learning through simulations. So simulation would get them a real world experience. They would be so curious in case you ask them what questions like whether you could predict what will happen or not. So this is really going to help. So one such example I will show you based on one of simple concepts. So what I have chosen is regarding photoelectric effect. So in the simple page there are a lot of facilities. We can see here we can change wavelength values and hence frequency values. Radiation intensity we can vary over here. Even applied voltage we can change here. And according to the parameters what we choose here, we will get a graph plotted. So first, let me take let me do a selection of material, 8 years sodium with curve function 2.27, and then fixing a wavelength which is less than of energy is at 2.12. Then we can see what no ejection of electrons. Now with wavelength may change and getting energy value more than 2.27. There will be emission of I can see the emission here now. So emission starts here. By the time we keep what the incident energy is somewhat higher than the work function. So here they get a clear idea about that the incident frequency must be equivalent to or more than threshold frequency. So we can have the initiation of photoelectric effect that can be made here. And now let's try varying the voltage values. So now because of potential I'm keeping as a 0. No current here you can notice. Now waver the potential from 0 to a greater value. So you get a graph plotter so that here we understand photo current at the maximum. So that's the saturation current which we can show them. Then in case for the same frequency and intensity, you reduce potential, apply potential back to 0. So here becomes no ejection. So ejection will be stopped. So that's when we have a potential applied in a reverse order. Say we call that potential to be stopping potential at which we get the whole of electrons to be stopped. And so the concerned energy is not to be treated as kinetic energy max because even the fastest electron we got a stop. So that concept can be made clear. Then now if you shift to a greater wavelength, and again if you start changing potentials, applied potentials, one second, I'm keeping intensity also changing, but frequency I didn't change much. So we are getting a split over the top section. So saturation current is varying with respect to intensity variation. So if you want to change, Or if you want to confirm, make an intensity radiation mode. Then again go for a potential radiation. So we get another higher level indicating saturation current is always to depend on intensity. So we get a connection between intensity and intensity of photocurrent and radiation very well. So they will understand they are going to be directly related. And for the same intensity, now if I alter frequency over here and try for the graphical section, the potential supplied by work, we are getting the cutoff potential shifted to some other point. So frequency are increased here, so we are getting to a greater point or to a greater potential cutoff value. So in case verification they want, they can try it also. Potential radiation, but cutoff potential here comes to yet another greater value here. So they use to what connect between frequencies and cutoff potentials. So the shape they can learn very well from here, and also the connections can be very well taught to them. So this is one case. So here also we have a lot of options to get them realized equations. So a mass connected to pendulum, it gives oscillation, and here we have options to change its length accordingly, or the changes in time period can be noticed. Given masses, for the mass dependence there for the time period of what we can give them an idea. Given gravity, how it influences time period, we can show them. We are correctly with this app or platform. And with mass is changing also, we can do the experiment. Even energy concept, we can keep them here. So here are the energy variations. Potential energy goes higher to the extremes. Kinetic energy becomes minimum at that becomes maximum at the middle point. Then total energy variation, everything can be shown here properly. And this is more interesting as we can see the orientations of velocity and acceleration as vectors. So yellow for the acceleration, which is always towards the center. So that acts as the retarding one, or that acts as the restoring one, which can be communicated easily. So this is a simple harmonic motion that wants to be. The same idea can be given to children directly. So such simulations are going to help us a lot when we want to show them an activity directly, but we fail carry out them in lab. So this is going to help them a lot. And also as a methodology, we can go for mnemonics to choose also. So this is something that we usually use. So that's for Onslow. And even bright children, they fail to shift the parameters rightly, even if they know the equation. So this such a technique may help them to choose for the equations rightly. So for example, if you write E as IR like this, the 3 power and then we'll make out D is going to be IR. In case I, if you want to separate, that's going to be E by R. So this is a technique to help slow learners. And this maybe it's like everybody uses in classes, that to choose higher resistance, we say if you go for the resistance which is close to voltage axis, that might be a higher resistance, we say. Then here for the record resistance, that's the equation. So RE, which is rho L by A. Replay will help for recalling that equation. So LE the Iceman, that's for understanding whether voltage or current that's leading, say between inductor and capacitor circuits. And another cone here for making out the electromagnetic waves in the order of lambda decreasing. So the code is this. Remember my instructions visible under X-ray glasses. So So each step starting letter of the words will get them recalling the electromagnetic waves in lambda decreasing. So then here, direction of induced current also they can make out quickly. Suppose I is increasing, let them give arrows in opposite directions to the closer sides. Then those arrows will decide for the flow of induced currents in the loops. In case current is decreasing mentioned, we are supposed to give arrows in the same direction to the loop. So those directions may decide for the circulation of induced currents in the loops. Then another equation is regarding resistivities in terms of relaxation time, which is rho, that is m by n e square tau, which can be recalled from the single sentence, say the city ROM is neat. ROM is neat. So they recall this equation, which is needed for having applied to many conceptual questions. So this trick is going to help them a lot. Then connection between V and the velocity, that is supposed to be a useful question in many of the examinations. So they can remember it like I am V now. So I comes to be VNA before VD, say with velocity. Then tau again can be a formula for torque to recall. Then usually while setting with ray diagrams, children fail to recall which lens could be of lower aperture. So I used to tell them in case of telescope E reflects more, so E can be, say eyepiece can be a smaller aperture. The same even that works with microscope. You can say O is more in that. So objective you can keep with smaller aperture. So such tricks, I feel like what is going to help children of all the levels, say no matter bright ones or slow learners, even bright children, what they fail to recall equations, they usually derive for the equations during examination time, which may consume their time a lot. So even slow learners will love to have such tricks. So these such methods are always helpful for children of any level. So that's it from my side. Thanks for the patient learning. Thank you, madam.
Thank you, Sachu madam. Shyam sir.
Good evening, Hema madam. Good evening, respected teachers. We have seen, had and experienced various aspects of this competency-based education from our Indian colleagues. Now, I'm trying to present my view on this topic, an activity which is based on parent capacity. And I recorded this activity by using my mobile. So there may be some sound problem, maybe video problem will be there, and not that much quality will be there. Excuse me for that. I think all of you may have done this in the lab, but still I want to show my view on this particular activity. Thank you. Madam, can you see this?
Yes.
Actually, we are performing an activity to just know the factors which are affecting the factors on which capacitance difference. So we have two parameters that we made from the model. These arguments I got it from the item that is applied for modelization of lab. So we made two capacitors like this parameter capacitors of different area. Or we are trying to find what will be the change in capacitance when you change the area, when you change distance, when you change the electric meter. So these all are this is what we have done. I'll just show the video.
So when we consider case 1, we found out the capacitance of capacitor A. Now we are going to capacitor B. Now when we use capacitor B, we start with the case the meter of radiation meter, that is 32 centimeters square. And we are not taking the distance into the case that is 3 centimeters square, and mainly the distance is L. So we are going to calculate theoretically the capacitance of these two plates. And we got a value of 31.4 millifarad. Next we are going to calculate, measure it in the same LCS meter. So we are going to connect it so we have a measured value of 0.023 nanofarad. And we are converting it into farad. So we got a value of everything into so we can conclude that theoretically and practically it is nearly equal. We can conclude that when area changes, when the area increases, the capacitance also increases. It's clear from the two cases. When we are considering an area of 0.04 meters square, we got an area, we got a capacitance of going to 10 to the next equal farad. And when we consider the case, when we take the area 0.074 meters square, we got a value of 10 to the next equal farad. So we can conclude that theoretically and practically, capacitance, the area increases capacitance. Now we are moving on to case 2. Here we are considering how the capacitance is dependent upon the distance between the two plates. So first of all, we are setting the two plates at a distance of 6 cm between them, and we have calculated the capacitance, which is nearly 5.9 10 raised to minus 12 farad. Now we are connecting our parallel capacitor through a LCR digital meter and recording the capacitance value. We are recording the value of 0.06 nanofarad, which we converted to farad form. 6 into 10 raised to minus 12 farad. Now, moving on to case 2, we are changing the distance between the plates. We are reduced the distance between the plates. Now we have changed the distance between these two plates. We have reduced it to half of the initial value, that is 3 centimeters. And then we have calculated the capacitance, and we put a value of 11.8 into 10 raised to minus 12 farad. Now we have connected a capacitor into the digital meter and recording the value of capacitance. We have recorded a value of 0.12 nanofarad, which we converted to farad is nearly 12 into 10 raised to minus 12 farad. So from these observations, we can conclude that as we increase our distance, the half of this initial value, our capacitance value becomes doubles. This shows that distance is inversely proportional to the capacitance of parallel capacitor.
So we have seen the effect of increasing the energy and distance between the two plates. This way when we see the medium as a test. Now let's change it and let's try glass as a medium whose diameter function, that is A, is unknown. Now first let us find the theoretical value of using medium as scalar. So C0 is equal to A epsilon naught by D. That means by calculation we get around 88.545. That is the theoretical value when we are using air as a medium. Now let's find it experimentally. So we are getting a value around 89. Now let's change the medium and use glass as the medium. direct. We are getting simple. Yeah, we can find the dynamic constant by the formula of C medium by C0. So, C medium is 0.262.
Right in picofarad, that is 262 picofarad is equal to 262. Okay.
So 262 by, we are getting 89.
88. Okay.
89. So 2.9. 2.9 is the approximate value that we get for the dynamic constant of the class.
Apparently, the capacitor there would be placed as a capacitance of 8 picofarad. What will be the capacitance if the distance between the plates is reduced by half and the space between them is filled with substance of a dielectric constant states? So, the capacitance of a parallel plate capacitor whose space between the two plates are occupied by a pair of vacuum is C equal to 8 picofarad. What we need is to find the capacitance when the distance between the two parallel plates are reduced to half, and also when the space between the two parallel plates are occupied by a medium of dielectric constant K equal to 6. So let us write the formula for capacitance, that is.
I think we don't have enough time to show this, but I made a little more video. They are discussing some higher order thinking problem in the classroom, and also with that they are just demonstrating how using that model. So that is what I have done as an activity. Now these are the sorry. Competencies that I try to attain using this one. So these are the competencies that I try to attain. The course is a 21st century skills like critical thinking. That is creative. Second one is creative thinking, collaboration, communication, and the competencies like problem solving, managing information together, and of course personal growth. So these are the competencies that I try to attain, and most of the students have shown a great interest in doing this activity, and even slow learners, they mastered this equation very easily. So I think it is a good activity. I think all of you might have done this. Thank you, madam. This is what I can present.
Thank you so much, Sham sir, and to all the resource persons who have contributed to this particular very interesting session. I think as physics teachers, we were all very much energized by the last session of today's workshop. In fact, the session by Sham sir was it exactly the essence of competency-based education, which students ultimately display the proficiency. This is the essence. I know that in classes, maybe you will be calling students for problem solving and other things, but this is one model I think we all can emulate, where this is an example for peer tutoring and learning. Another example for experiential learning, whether students actually experience, analyze the parameters, understand the observations, interpret the results, and able to explain the things based on their understanding to others with confidence, a lot of self-confidence, and with good communication skill also they have displayed. So this itself, I need not explain more. Actually, I am overwhelmed by this last one specially, and all the small parts enacted by all the teachers in competency-based activities in this particular session. It was a combination of, when it comes to Ramchandran sir session, actually a lot of things which are available in the laboratory, if we pay a little bit, take a little bit time to work on it, very complicated concepts can be shown in a very simple way, and students will be interested to see. Then how ICT can be used, like in Sachu madam's case, that FET simulations. This we have seen last year also, but once again, after a long gap, when I was going through this again, it was so much interesting to see how the graphs, actually in photoelectric effect, the graph is one very important area. All the questions will be based on understanding of the graphs, the behavior of behavior under various voltages and all that, intensity, frequency and all that. So that is one way. Then solving problems, like Prashant sir told and Srikanth sir told, solving problems, how to approach a higher order thinking skill problems. Then Vilesh sir was discussing about once again that activity in lab in which even students can also perform. So all the resource persons in this session have shown in different ways. Actually, no two sessions were alike. In different ways, how competency-based teaching can be done. And finally, the result should be what in the ultimate, the last presentation of Sham sir, that should be the effect. Finally, students should be able to display something. This is one thing we should remember always. At the end of each and every one of your class, students should be able to display that competency. Please keep that in your mind. I would also take 1 minute to thank all the teachers who acted as resource persons and deliberated each session to that very finest, minutest detail. So it was a very long day today, but it was a very enriching session. Very exciting session, especially last session. It was very exciting. I think this competency-based education. Sham sir has uploaded the video in, I think, your YouTube channel, school YouTube channel. So yeah, please do it. If you have more videos, please do it, because everyone can easily access it. It will be useful, and just paste the link in our group. This is one very important activity. This kind of activities, if we show children, they also will be interested. Their counterparts in different schools are performing these activities. And there are a lot of conceptual questions that come from these areas. So if ever you have done, even I will request Ramachandran sir, I will request Vilesh sir, whatever experiments you have done in your school, and make more students to be involved and upload in the school YouTube channel. It will be useful for everyone, and share the links with each of us, so that that will help in effective competency based teaching. Once again, let me thank each and everyone. I am finishing in a hurry because already the meeting has started there. So I have to join in that meeting too with Aro. That is why, otherwise I cannot, but thank you all enough for such a wonderful day. Each and everyone who contributed, not just the resource persons, each and everyone who contributed, who interacted, made this day wonderful. I hope that this kind of a meeting, maybe at the latter part of the year, in the second term, once again, we should meet again for the competency-based experiments we are doing in our classes. Experiments by teachers. It's not just physics experiments. The experiments, the innovations teachers have undertaken, I think it is a meaningful thing to share. Rest everything we do under obligations as teachers, like curriculum, adapting the split up with the time available. All these things are other things, but the excitement doing physics in classroom gives us is entirely different. It gives a different feeling. So I'm happy that we concluded today like this in a very meaningful way. Wonderful by each and every one of you. Thank you, everyone. I'll disconnect now. I think we will continue to interact more.
Thank you.